Alright folks, today we're going to work on something a little bit different with note taking. We're just going to try it, let's see how you like it. If you don't like it, that's okay. We're working on 9.2. So 9.2, which is properties of logs. And specifically working on this thing I call, and not I call, lots of people call, the change of base formula. So this formula is used when we have problems like this. So if I said 2 to the x equals 1/16, you're like, okay, I can rewrite that in logs. We've done that before. So we can say this is the same thing as saying log base 2 of 1/16 equals x. And that's saying try to figure out some power that you can raise 2 to, to get 1/16, which is like, I don't know how to do that off the top of my head. So let's talk about this thing called the change of base formula. So this will allow us to solve problems like this. So it's called change of base. First, let's talk about base of logs. So when you see a logarithm, right, it just says log base 2 of 8 equals x. Our base is the same base they're talking about for the exponent. So the base for this log is 2. And that's what we're looking for. This change of base formula allows us to change the base to whatever we want. So for any log, where we have log base b of a. So that's saying we have some base to some power, and yes, we know it gives us an answer, so we can write it like that. We can change the base of this by saying, hey, let's use log base another base of a divided by log of another base of b. And you ask the question, Mr. Seaman, why is this helpful? Well, here's the problem with these calculators and a lot of the calculators they use. They operate natively in base 10 and base 10 alone, which says they only, so calculators, only do log base 10 of your number, right? That's all they do. So if we want to actually solve something and use a calculator to help us figure that out as opposed to playing a guessing game, we have to make it base 10. So let's talk about this example up here. So this is our change of base formula, by the way. I'm just going to box all this in. So this is why we do it. This is our base, reminding us what a base is. So our example 1. Let's solve this problem. So we said 2 to the x equals 1/16. We can rewrite that using logs by saying log base 2 of our answer equals our x, which still doesn't give us a whole lot of sense. But we could then rewrite the log base 2 of 1/16 as log of base 10, which allows us to put in a calculator, of 1/16, just whatever this part of it is, whatever the answer is, divided by log base 10 of 2, just your base. So this big number goes on the top, and the little number goes in the bottom, and they have a common base, which we can rewrite this when we don't have a log. If we do not have a base number, we're assumed to be log base 10 divided by log of 2. So we just need to type this in the calculator now. So, get my handy dandy. We can say
log of 1/16, that's just division symbol, folks. Remember that fractions just division, and close parentheses when your log's done, divided by log of 2. And it's going to tell us the answer is -4, which is handy because we know that log base 2 of 16 is what our solution is. So we can say x equals -4. So, no guessing game. We can just solve that one. Okay, so let's go on to example 2 here. So example 2, let's say we're doing 32 to some power equals 2. Well, okay, let's rewrite this in log and see if it helps. Log base 32 of 2 equals, my exponent does not help me whatsoever, but I know that log of 32 divided by log of 2 divided by log of 32 equals my answer. So let's just say x is going to equal, let's see here. Okay, handy dandy calculator. We'll say log of 2, close parentheses, divided by log of 32, close parentheses. 0.2, which will make that into a fraction, 1/5. So you can get 0.2 as your answer, but I like the fractional 1/5 better. That says 32 to the 1/5 power should equal 2. So let's just check that. 32 to the 0.2. Yeah, it equals 2. Okay, it works. So we get 2 equals 2, which is a true statement. Woohoo! Okay, last example, example 3.
So let's say for a second that you're like, hey, I've got some weird log. I want to know, when you raise 2 to some power, when does that give you 3 as an answer? So we're going to write this in logs. So log base 2 of 3 equals our unknown. And then we're going to use the change of base formula. So log of base 10 of 3 divided by log base 10 of 2 is equal to our answer. So x equals, let's see, log base 3, or log of 3 divided by log of 2. So give us a decimal, 1.5849, and so on and so forth. Dot, dot, dot. So this is approximately equal to, now it's not exact. So we could say 2, my answer should give me 3. And it does. Fantastic. It works out. So not only does this allow us to not play a guessing game anymore with our logs, it allows us to change the base to whatever we want, and this will be useful later in calculus when you come across things like that. All right, folks, and let's get to practicing.